Well, good afternoon, everyone, ladies and gentlemen. Thank you for joining us for today's session, Who Gains When Robots Rise? Well, first, let me have the priority to introduce our distinguished speakers today. His Excellency Dr. Majid Alfayyadh is the CEO of King Faisal Specialist Hospital and Research Center. Himself is a distinguished physician executive shaping national healthcare and healthcare innovation. And the next, Dr. Hiroaki Kitano-san is the president and CEO of Sony Computer Science Lab and also a global pioneer in AI, robotics, and system biology. He has been dedicated in the effort of building AI systems capable of making Nobel-level scientific discoveries. And then next to him, Dr. Ying is the founder and managing partner of Atma Capital. She also previously co-founded Rubin Capital together with Jack Ma, investing across AI, sustainability, and healthcare technologies. And last but not least, Rubin is the founder and CEO of Genki Robotics. And he himself is the legendary entrepreneur behind Android, Danger, as well as Playground Global. So he has constantly pushing the boundaries of how technology can reshape everyday's life. So without overdue, let me turn first question to Dr. Majid. So your hospital is celebrating the 50-year anniversary this year, which is quite remarkable journey. Can you share with us the vision of the hospital and how it is becoming the playground and transformative fields for robotics in healthcare sector?
Thank you, Casey. Yes, actually, King Faisal Specialist Hospital is a tertiary center that's this year celebrating its 50th anniversary. 50 years ago, the late King Faisal wanted to build a hospital that gives sort of the cutting-edge healthcare to people of the land in our region. And 50 years later, I could say that vision has been answered, and now we are embarking in another vision, another challenge, is to take that excellence and innovation globally. And this is a new direction we are taking. Now, part of that, in order to be a global hospital, to be counted among the top hospitals, we looked at our strength and we looked at the gap in the national and international arena. And we thought that biotechnology, genomics are two areas that are very essential and we could invest in, but also digital, and in particular robotics. So 5 years ago, we upped our investment. We increased our investment in robotics, but the investment did not start there. We have robotics implemented in our lab, in our pharmacy, in our supply chain, and actually in the coffee shop. We have a robot that fixes the coffee for our visitors. However, once we saw the benefit of robotic operation in the pharmacy has decreased the errors and also decreased the infection in the lab using the robot, we went a step ahead and we introduced it in the patient contact area, namely in the operating room. So now, we do 7% of our surgeries using the robot. We do about 40,000 surgeries per year at King Faisal, and about 7% our patient chooses to do it through the robot. And that was an investment that we introduced the robot in the operating room in different areas, and we've seen great success. Very enthusiastic workforce. They want to adopt the technology. There is a challenge among our staff to who does more, who does it better, who does it more efficiently, and we just couldn't answer our surgeons' request, wanting more robots. And success begets success. So this started about in 2019 when we sort of reintroduced robots in the operating room. And most recently, we have done the first neurosurgery using robots. And just to sort of give you the picture, it's a golf-sized ball in somebody's tumor in a brain. And he is a 36-year individual who had this tumor in his head. We were able to map it and reconstruct it using 3D. And then with the help of the robot, sort of to master very fine movements, our surgeons were able to excise that tumor, which is about golf-sized ball, as I said. And the remarkable thing, because the surgery was so precise and so well planned, the patient, after his head opened, removed that tumor, walked home in 24 hours.
Wow.
Now, that is the latest, but before that, we've done the first transplant, liver transplant, end-to-end in a pediatric patient, and before that, we were also made headlines when we performed our very first robotic heart transplant. And it's showing that it pays off. So it's not only interest, it's not only patient experience, but it's also in other areas of cost cutting and what have you. So we're very enthusiastic about our robotic experience, and we are planning to expand it, offering it to patients as a first choice rather than an option. And we see the benefit, and I think it's going to get more.
Yeah, I think that's truly exciting breakthrough that we see robots start touching people's human life in real cases. So turning to Dr. Hiroaki, you have long argued that AI and robots must evolve from automation to scientific discovery. So as we are approaching the AGI world, how do you define the current level of intelligence and automation in the scientific discovery field, and what has Sony Lab been focusing on recently?
Oh yeah, I mean, AI and robotics has been evolved through the grand challenge of moonshot. This is a history of the AI, like winning world-class chess champions, or game of Go and autonomous driving, all that. Like back in 2000, late 90s, I created the initiative called RoboCup, which is like by 2050 to create a fully autonomous human-robot team to win the World Cup champion. This became like a world global initiative, and then I think over 35 countries and 1,000 researchers get involved, continue to achieve, trying to achieve that goal. Now, that is more the intelligence and the physical things, like millisecond reactions and the physical coordinations, and that's the target. Now, for the scientific discovery, if you look at this, what is the most important thing an AI can do, AI robots can do, is actually push the science. And because our civilization is based on science and application of science into technology and how to deploy it. So I define like a scientific discovery, automating it, creating a warp engine for scientific discovery is one of the most important things AI for robotics. Now, what's going on right now is we have like a highly automated laboratory system. Like in my lab down in Okinawa, we have like a no human in the loop metagenome analysis package in a nice robotic system and an AI system to be able to create a hypothesis and verify that. So right now, science has been done predominantly by human beings. But if you look at the biology, it's so complicated, it's so complex and vast, and very difficult for human to actually capture the complexity of even the smallest cell, like a yeast or E. coli. It's still very difficult. Now, for the human beings, like it's a very complex, all the medical practice indicates, and we need help. We need to actually work with AI and robotics to be able to conquer the complexity and vastness of the human physiology and the human biology. So therefore, we need AI. So what is the paradigm change is AI will consolidate very large number of the papers and data and create a network of knowledge, which is very consistent, and create thousands of hypotheses, not just one or two. If the human science do science, we come up with one or two hypotheses, expecting that is right. But instead of doing that, we generate a lot of hypotheses, all of them consistent, but we actually populate the entire hypothesis space and come up with a series of experiments that can quickly verify the search through all the hypothesis space, which one is actually the most probable one. So and then go back in that stage and verify that and go to experiments, and then we need automations. Okay, so current biology practice has been designed to do the experiment against one or two hypotheses. What happens if you have 1,000 hypotheses? We have to do the completely different paradigm doing experiments. So we need a robotic system to be able to do the experiment, and then a hypothesis generator to cope with that. Okay, and one stunning statistic is among 40,000 human genes on the human genome, guess how many genes have papers? Well, the recent stat says 16,000 of them, almost half of them, has no paper. Okay, 7,000 of genes has only one paper. So we are actually navigating in a very skewed landscape. And the reason why those genes don't have a paper is that people want to be successful, so people bet on the genes, which is more likely to be more important. People randomly pick the genes and try to investigate and take years. So this is human psychology. To overcome this, we need robotics and AI to speed up, and we go to those dark matter in the human genome and discover something very important, which we haven't been able to discover. So that's a whole paradigm change we're going to see in the scientific discovery in coming years.
Very interesting. Completely AI, autonomous, no human in the loop, no human bias in the process.
Exactly.
So turn to Dr. Andy and come back to Dr. Ying. So Andy, you've created multiple platform shifts in the past, from Android OS now to robotics. Can you just share with us your thinking process historically in the past? How do you think about the why not question and continue to push about the boundaries of what is possible in the future?
Yeah, thank you, Casey. So I think in terms of ecosystems, and ecosystems form around platforms. So if you go back in time and you look at computing platforms, we had mainframe computers, very few users, very expensive machines, right? Did very specific things. And then we start with the personal computer. All of a sudden, we have a computer that's relatively affordable. People can take it home. They're doing more things with it. And the market, obviously, is larger. When you take all of those computers in people's homes and connect them together, you have the internet, right? And the internet then enables lots of people globally to share information. And what do they want to do? They want to take information with them. So they want to cut the cord and take their PC with them. And all of a sudden, you get the cell phone, right? And each wave of innovation here builds upon the previous generation. So we wouldn't have the internet unless we had personal computers. And we wouldn't have mobile unless we had the internet. So as these ecosystems grow, there's business opportunities. And what's fascinating about the largest ecosystems that grow around platforms is there's a business opportunity that has a flywheel effect, right? And the whole solution and the whole opportunity gets bigger and bigger for everyone if you can distill it down to its basic form. The first enabler is a generic device. The PC was a generic device. The mobile phone is a generic device. They all kind of look the same. I don't know, if we all put our cell phones on the table, I don't think the audience could say that one's an Android phone and that one's an iOS phone. But once we have something that's, a touch screen, right, what makes the product useful for us is the apps that we put on it, right? And all of a sudden, you have a generic piece of hardware, and the utility is the applications. And that's how an ecosystem forms, because you can have many, many applications, whether it's a banking application, a social media application, or the app you guys probably downloaded to attend this conference, right? So once those apps are being developed by developers, the utility of the generic device becomes bigger and bigger. And the flywheel starts spinning because the developers make people want to buy more phones. And when people want to buy more phones, it creates a bigger market opportunity for developers. So ecosystems, for my entire career, I've been chasing them. And obviously we had mobile, we had personal computing, and now we have AI. And I believe there's a huge ecosystem opportunity in AI once we cut the cord and allow kind of your PC to sprout legs and participate in the world alongside of us.
Yeah, the future is beyond imagination. I heard recently Elon predicts that in the future there will be no more mobile phone, no more app. You just get what you want instantly. So turning to Dr. Ying about capital markets, so you've been investing in deep tech across US and Asia for a long time. So in today's robotics wave, where do you see the most investable opportunities? In which specific vertical domain or in which region do you see the opportunities?
Yeah, so I think investing, it's about how do you lower the risk to maximize return? And of course, investing in somebody like Andy, who is a serial entrepreneur, have done things before successfully, would definitely lower the risk and increase the chance of success. However, there aren't that many Andy around that we can invest in. So there are a few strategies we can perhaps deploy. The first one is when there's a gold rush. The people that actually makes a lot of money are the ones that sells the picks and shovel. So in the robotic world, similar things are happening. For example, we see a lot of the robot demo look very impressive. But if you know that how they were produced, you see many hours of shooting, and it's fast forward 1.5 to 2 times. So they can act in real time, and that limits their application. So we invested in a company that's actually using the Sony event-based sensor to allow real-time robotic interaction on a fast-moving assembly line. So besides investing in the picks and shovel, the second strategy is, like Andy mentioned, we can look at parallel industries or things that happened historically. In the hardware space, we see semiconductor, which is a very well-established industry today. But at the very initial phase, when people are designing chips and getting those manufactured, it costs a lot, and it's very time-consuming. Until the Cadence, Synopsys, all the simulations tool came out and can mimic real-time, real-life situation more and more accurately. And so for robotics, we are also fortunate to find companies that are solving this data problem. For the LLM, they're so successful because there are tons of data available. But for the robotics world, there aren't as many spatial or 3D data that the robot can be trained on. So by developing very good simulation tool, you can synthesize more spatial data to train the model on, and you can also simulate the movement, the angles, the force, etc. So then it can scale faster and better. And of course, the third strategy, which has been echoed throughout this conference, is about partnering and working together. So as an investor, we don't know everything, and in fact, we know very little. However, we have experts from the industry, like Dr.
Alfayyadh.
Majid, sorry, and Dr. Kitano. They know from the customer's perspective and the corporate perspective what really can help them and what really works. So by partnering with them and co-investing or helping the companies together, they'll have a higher chance of succeeding. And in terms of vertical, there are actually a lot of verticals that has already proven unit economics and also good payback period in logistics, warehouse, hospitals, construction, inspection, farming, etc. And in general, how the different continents differ is in the US, we are very good about advanced science, building platforms, and operating systems to get the ecosystem going. While in Asia, the engineering part is very advanced. They can deploy things very fast in large scale and at a very cost-effective manner. So we think that if we can combine and partnering and work with this whole ecosystem, we can potentially accelerate the robotic era.
Yeah, fantastic. I think both you and also Dr. Hiroaki talking about data, the importance of data. So, Dr. Hiroaki, in your role of scientific discovery, how do you think about the high-quality data, explainable data infrastructure accelerate in the discovery process? And is there any challenge that you're facing right now?
Yeah, actually, we need a multitude of data. It's not just a one kind of data. If you look at the highly dynamic or complex system like a biology or probably material science or a global ecosystem, you need data on the, probably 10, 20 different kind of data minimum, and probably you need to scale up to 50 or hundreds of different kind of data with very large volume. So I think handling the data and how acquired high-quality data is critically important. And one of the reasons why AI training is so expensive is you need a long tail side. Okay, you have a data that happened very frequently, very stereotypical part of the event. That's the easy part. But the question is, the issue is a long tail part, which is kind of event which happen probably once in a month, once in a year, once in 10 years. Accumulation of that part is non-negligible. It sometimes go up to 30% or even 40%. The leaving that actually is significantly undermine the quality of the robotics in behavior in the open world or an AI system in a scientific discovery or autonomous driving. And then how to handle that the long tail part of the event, statistical distribution, is extremely critical. So if you take a look at the robotics and AI system scientific discovery, this is open world, right? And if it's a factory robotics, that's closed world. You can control the environment. You don't have the exceptions. So that's easy. Well, I wouldn't say easy. There's some complications automation and factory robotics as well, but like in terms of data, you can manage it. Once you go to the open world, like autonomous driving, things happen, like things which haven't imagined happen, and that's non-negligible. That's why you need to invest a lot. You have to come up with the technology, and that part. We actually, in the area of AI and robotics deployed in the open-ended world, therefore, we have to face long-tail part. And that's really critical. And then how you create like monetize it, you get the economics on how you recoup the investment while you start keep collecting a long tail part of the data, which is very expensive and time-consuming and computationally very expensive. It is like the key factor for make a business success and make a system viable in the real world.
Completely agree. So data is the blood for AI system to operate. And in finance industry, that we're facing the same challenge that winning information, we deal with decades of financial information. Collecting those information, cleaning those information, aligning, that is important to address the accuracy hallucination issue to lead to AI adoption. So turning back to Dr. Majid, we talk about the investments is quite intensive in the early healthcare research. And how do you evaluate the returns, the benefits that it may come in the future, probably with no predictable outcome?
Yes. Now, going with this investment in terms of introducing robotic in the healthcare and hospitals in particular is not cheap. So there is a heavy capital investment. Not only that, there is also training, intensive training involved in that to get the right team to operate these robots accurately. However, we have seen the return. And as I said, when we introduced it in the non-clinical area, sort of non-patient contact area in the lab and in the pharmacy, in terms of reducing error and more efficiency. But it has nothing more impressive than what we have experienced once we saw clinical. So now our patient who has surgery, like a heart surgery, and instead of having a long scar from the bottom of his neck until the top of the abdomen with the chest cracked open, with all the infections, bleeding associated with that, they leave home after the cardiac surgery with 3 small incisions in the side of the chest. That is tremendous patient experience. That decreases the infection, that decreases the length of stay, that decreases the medication used, and all of that return into financial. So our average after heart transplant length of stay is about 1 month. It was reduced to 10 days. And after brain surgery, it's 5 days. It's reduced to 1 day. So we see the return on investment in saving, but more importantly in quality. And quality is not cheap. As I said, it is a heavy investment in the initial phase, not only as far as sort of the capital investment, but also in training. But we have seen the payback of the investment, and we intend to increase it.
Great, awesome. So my last round question, given that we're out of time, I'm going to quickly go to Andy to talk about what's the why not problem you're solving for next phase, and in the future, how do you see AI human collaborate to help human upscale and augment?
Yeah, thank you. Well, I view AI as a tool. If I look at my kids and I see how my kids are using ChatGPT, they're asking it questions so they can learn, so they can get the information they need to satisfy their curiosity or maybe to do their homework, I don't know. And when I was a kid, the controversial technology in my middle school was calculators. Pocket calculators. The parents were in an uproar. Should we allow the students to use calculators in class? So these tools, we go through these societal shifts where these tools become, part of our everyday life. And the moment they appear, there's a little bit of uncertainty and a little bit of discomfort around that. AI in general, as it's kind of, pushing the innovation curve, you'll feel that same discomfort. But the way I consider it is it's a tool. It's a tool for me to do my job better. It'll be a tool for my kids to do, whatever they need to do. When you combine that with robotics, it becomes a multiplier of productivity. It multiplies my productivity in a way that Kitano-san described, where we couldn't do it because there's just this vast amount of things that need to get done. But when we couple ourselves with 10, 20, 100 robots, we can do a lot more, right?
Yeah, the future is beyond imagination. So one last sentence from Dr. Ying and Dr. Hiroaki on any lesson that the Western world can learn from Asia?
Yes.
One sentence from each of you, the golden sentence.
Be practical.
Get into the details.
Attention to details, very, very Asian culture, be practical, be quick to adapt. And thank you very much for joining us for the discussion today. We all hope that to continue the conversation in the future. Thank you very much.